have to see Unit 11 Carbon and its compounds. In this lesson, today the session will be Ethanoic Acid, the structure, physical properties, chemical properties and uses. Okay, first we go to structure of ethanoic acid. CH3COOH is the structural formula of ethanoic acid. See here, the structure you draw means like this you will given double bond OH and this fully hydrogen, that's all. So this is the structural formula and normal formula is CH3COOH. Okay, next the common name is acetic acid. The common name of ethanoic acid is acetic acid. Okay, how it will be manufacturing? Nothing but it is oxidation of ethanol in the presence of alkaline potassium permanganate or acidified potassium dichromate. It gives ethanoic acid plus water molecule. How it will be formed? See here, you write it as CH3 CH2OH. This is the formula of ethanol. Okay, here the two hydrogen will be emitted and one oxygen will be addition. It gives CH3COOH with liberation of hydrogen. This hydrogen combined with enormous of oxygen to form H2O. Okay, this is the identification of alcohol also. Already I say the potassium dichromate color, orange color is changes into green color. It is identified the alcohol. Okay, next manufacturing of ethanol, that is given in your book. Ethanoic acid is prepared in a large scale by the oxidation of ethanol in the presence of alkaline potassium permanganate or acidified potassium dichromate. Alkaline means the potassium permanganate is dissolved in base. Acidified means the potassium dichromate will be dissolved in acid. That is known as alkaline and acidified. Okay. Next, properties of acetic acid. Properties of acetic acid is a colorless liquid. It has a sour taste because it is a acid, so it is a sour taste. Smell and insoluble in water. The boiling point of acetic acid is 391 Kelvin. How will you convert it into Celsius? See here, you write the boiling point of ethanoic acid. Subtract 273. You get the value 11 minus 3 equal to how much? 8. 8 minus 7, 1. 3 minus 2, 118 degree Celsius. This is the degree Celsius, conversion into degree Celsius. When acetic acid reacts with base, it gives salt and water. That is one of the example they given. Next, uses of acid. It is prepared of a white lead as a good laboratory agent in the preparation of vinegar. Vinegar you know very well, that is used in the pickles to preserve it. Okay. Next, physical properties. Ethanoic acid is a colorless liquid having a unpleasant odor, that is it will be giving a sour taste, that is unpleasant smell to our nose. Okay, it is a sour in taste. It is miscible with water in all proportion. Boiling point is higher than the corresponding alcohol, aldehydes and ketones. Its boiling point is 118 degrees Celsius, 391 Kelvin. Okay, on cooling, pure ethanoic acid is frozen to form a ice-like flakes. That is, you know very well, in Arctic side, the ices are presented as a glacier. That is layer by layer. That is known as glacier. That form of acetic acid will be known as glacier acetic acid. It is a pure form. Okay. Next, chemical properties. You know very well, acids turns blue litmus turns to red. So ethanoic acid is a weak acid, but it turns blue litmus to red litmus. Second one is reaction with metals. See here, Metals like sodium, potassium, zinc, any metal you take, you know the valency of that metal. Okay, now I draw right here. See here, it will be splitting like this: CH3, COO minus and H plus, and Na is always Na plus. Okay, this Na is combined with this CH3COO H, and H will be liberated. So CH3COO Na plus H2. Here zinc valency is Zn2 plus. Cross multiple means you get CH3COO twice and Zn plus liberation of H2 gas. So ethanoic acid reacts with metal like sodium, potassium, zinc to form a metal ethanoates with the liberation of hydrogen gas. Okay, next reaction with carbonates. Always the same formula. Ethanoic acid reacts with carbonates and bicarbonate, produce brisk effervescence because there is a liberation of carbon dioxide. Wherever the liberation of carbon dioxide, there will be a brisk effervescence, formation of carbon dioxide. So salt plus water plus carbon dioxide. As it reacts with carbonates and bicarbonates, it gives salt plus water plus carbon dioxide. Okay. Next, reaction with base. Ethanoic acid reacts with sodium hydroxide to form sodium ethanoate and water. The same reaction, it will be splitting into CH3, COO minus and H plus. This one Na plus and OH minus. These two combine together and hydrogen and OH will be combined. So CH3COO Na plus H2O, sodium ethanoate plus water. Okay, next decarboxylation. What is meant by decarboxylation? That is removal of water. Before ethanol, in chemical properties we see that dehydrogenation and dehydrogenation. Dehydration means removal of water molecule. Dehydrogenation means removal of hydrogen. Here decarboxylation, that is removal of carbon dioxide. When sodium salt of ethanoic acid, before itself we see no CH3COO Na, that is sodium salt of ethanoic acid is heated with soda lime. Soda lime is nothing but 3 part of sodium hydroxide. This one 3 part, that is sodium hydroxide is 3 part, and 1 part of calcium oxide, that is 3:1 ratio is known as soda lime. With addition with this one, it gives methane gas. The CH4 is methane plus sodium carbonate. This reaction is known as decarboxylation because of molecule of carbon dioxide is removed from a molecule of acid. So it is known as decarboxylation. Okay, next, you know very well, lot of uses are there. In your book they given only little bit. Acetic acid in a lower concentration is used in food additive as a flavoring agent and a preservative. You know very well, vinegar we using for a pickles to preserve it. Okay, next uses, it is manufacturing in plastic. It makes dyes, pigments and paints, in printing on fabrics, as a laboratory reagent, for coagulation of rubber from latex, that is the rubber milk is converted into solid form by using ethanoic acid, that is known as coagulation of rubber from latex, in the production of pharmaceuticals, that is medicines. Okay dears, today the lesson will be over. Tomorrow we will meet.